So I'm Greg King. Let me go ahead and share my screen. I'm going to share this. I noticed in the poll that I don't know if Suraj, if you wanted to answer that question, or I'm going to answer it, but I will say it. Full stack DR actually works across availability domains or two OCI regions, but it isn't OCI, OCI to OCI regions. It's between OCI regions is our service right now. We have on a roadmap, but it's pretty far out there to do hybrid and multi-cloud, but that's at least a couple years out there. So let's take a look at what we have right now. I probably need to, there we go. I think we're good. All right, so I'm going to talk very quickly about this. Like I said, oops, it is DR at scale. So when I'm showing business system, when I get to the demo part of this, but you might have, if you're in IT operations, you might have several different business systems that are entirely separate from each other. And right now, probably if you're doing this by yourselves, if you actually do a recovery of some sort, even a test or anything like that, you're going to spend all the time working on one of your business systems. And when you're done with that one, you're going to move on to the next one. So if you spend a couple hours doing one or a few hours, then after you're done with that, now you have the resources that you can focus on the second one and the third one and the fourth one and the fifth one. And pretty soon, a week later, you've actually got everything moved over and recovered. This allows you to do all of them at the same time if you want to, one or many at one time. Completely different system. So that's DR at scale. So in that same 2 or 3 hour or whatever time you were taking to do it, one system, you can now do two, three, four, five, or six or more. We give you the ability to validate DR before it's needed. So we'll talk about a couple different things here a little bit. You have pre-checks, and then you also have what we're the new one, the new features we're going to talk about is DR drills. Suraj is going to cover that a little more, but a DR drill is a full failover without impacting your production. So very interesting for you. You can capitalize on existing effort. This is really important. If you have not adopted full stack DR yet, and you're thinking about it, and you've already spent some time building some automation or things that you call throughout your current DR process, then you don't have to throw that away. If it makes sense, you can incorporate it into a DR plan. And then use any DR topology. I'm not even going to tell you all the different things that we can do. If it's something you want to do, we can do it. Hot, cold, warm, active, active, pilot light, VM failover, all of the above. Okay, so we don't have a particular way that you have to do your DR. You do it your way. All right, so let's talk about little things. So for the people that haven't done this before, or seen this before, I'm going to talk about a few concepts that you're going to need to know for the little demo that I'm about to show. All right, so what we do is we have a logical construct that's called a DR protection group. You will create DR protection groups in each region, and then you will, I'll show you here in a second, you associate those two protection groups to work together. They're peers of each other. And then you can have several of these pairs of DR protection groups. And each one can do a completely different, like one is your supply chain management. The other is your customer relationship management. The next one is your sales portal. The next one is, it doesn't, you can put whatever you want in these things. One of them could be your system admins have a bunch of tools and things, and they just need those moved from one region to another. Okay, you can organize this any way you want to. When you create a protection group, you add members to it. And I'm going to show you members in a minute. Members are all the resources. You got 1,000 virtual machines and 26 different databases. Out of the 1,000 virtual machines, these 10 or 20 or 30 or 40 are part of this business system. Ignore the rest of them. Right? These out of the 26 databases I have, I want this DRPG to manage two autonomous databases and an XSCS and base database. Okay, so that's what you do. You add members. Block file system. We'll talk about all those things. Okay, now that's what I was talking about. Now you take those two DRPGs and you associate them together so they're working as a pair. They're peers of each other. And then you add members, whatever is running at your primary region, you add those as members. And whatever you have running that is part of the same business system at the recovery region or the standby region, you will add whatever's running over there as members. Then we have, now that creates all the relationships between things. What is part of this business system? We've just defined it, and we've also said, here's my primary and here's my secondary. And the role of primary and secondary is the role of the protection group, not of the region. It's important to understand that. A region can be both a primary and a recovery for two completely different business systems. So you don't need to take out of your mind that one of my regions is standby and my other one is production. You can do that if you want to, that's fine. But just keep in mind that once you've taken one of your business systems and you've moved it from primary region over to standby region, that for that business system, the region you just moved it to is now the primary for that business system, while you still have other systems running at the primary that was the old region. So just remember that the function of primary and secondary for us is these protection groups. All right, now after you define that relationship, you're going to create plans, which are what do you want us to do during a recovery? And that's what the DR plans are. And DR plans have two different types. We're going to talk about those. Suraj is going to talk about those. We have failover and a switchover. A failover is we are only going to do the operations at the standby region because we're going to make sure that or make an assumption the primary region is no longer available. All right. So in a failover, we're only going to do things at the standby region. And a switchover is planned. For some reason, you need for compliance or whatever the reason, you need to move your workload from primary or region one over to region two. All right. So a switchover, you're going to plan it ahead of time, a month ahead of time at midnight, we're going to do this. Right. And so you will switch over from one region to another. So we are going to do things at the primary region, region number one, and then we're also going to finish it all up at region number two, which is your standby region. And when it's done, now your standby region is automatically going to become, for that particular business system, will now become the primary. And it's all ready to go back the other direction. You don't have to do anything. All right, and I believe what we're going to talk about is the failover, switch over. That's what I just talked about, and then Suraj is going to talk a little more about these drills, a start drill and a stop drill. These are two new features. And then lastly, I'm going to show you pre-checks here, and then I'm going to show you the difference between built-in plan groups and user-defined plan groups. User-defined plan groups are how you customize it to do whatever you want to do after we've built a plan that has all these pre-populated steps that are built in. These are things that we already know how to do that you don't have to think about or figure out. And then for those things that we don't know how to do that are unique to you or your applications, you will then add user-defined steps. And we're going to see that pretty soon here. So now I'm going to show I'm going to go ahead and show my a video here. Let's see, where is my video? Right here. All right, so I'm going to share the screen, if you will. There we go. You can see that, Suraj?
Yes, great.
Okay. I'm already sharing sound, so I'm going to play this video right here. I'm going to back up just a second here on this video. This is a whole playlist here.
I'm Greg King, the product manager.
Stop, Greg. This is a playlist in YouTube that has I'm going to put this away for a second. This has a lot of videos. Now this doesn't have the new features. What I'm about to show you after I show you this video, you'll see on the right-hand side here, and in this video, I'm going to talk about My App 01. Okay, these videos right here don't have the new features in them yet, and we're redoing the videos for it. And that is what I have over here on the right-hand side of the screen here, is the new version of this video I'm going to play for you. But I want you to see that there's other things out here. So I go through a full video here that explains, the high level what full stack DR does. Then this is the key technical concepts. So that slide, the last couple of slides I showed you with what a protection group is and all that kind of stuff, that is, and more, much more, is explained in this video right here. And it's only 9 or 10 minutes long. I'm much better. I scripted all these, so I go through them. It's very concise and crisp. You'll find that I talk too much here and get distracted by things. So these are right on topic. And then this one is 100% of every step you're going to do from beginning to end for implementing automated DR for any application you do. It doesn't have any application in it, right? But it tells you every step that you have to do. So whatever you perform in here is the same exact process you're going to use for anything. And that's in this is a really long video, but it has everything in it. So I'm going to go ahead and play this one right here. And I'm going to make sure
about the application being recovered.
Let's go.
I'm Greg King, the product manager.
Now you all can hear that?
Yes.
Okay. I'm going to make it full screen and we're going to play it and I'm going to be quiet.
For full stack DR. So, what does full stack DR look like in the OCI console? The key benefit I'm demonstrating today is that the person executing the DR plan does not need to know or understand anything about the application being recovered or have any specialized skills. You still need highly skilled technical resources on your recovery team, but they can focus on solving problems rather than being bogged down typing commands at a keyboard. I'm going to step you through the entire process of executing a switchover using full stack DR with the click of a single button. Now watch closely because the process only takes about 30 seconds. Let's begin. Navigate to Migration and Disaster Recovery in the OCI console. Select DR Protection Groups. Select the DR Protection Group for the business system, which is cleverly named MyApp01 in this demo. Remember that DR plans must always be executed from the standby protection group. This is the primary protection group, which means I need to change my context to Phoenix since that is the standby peer for this protection group. Now select the protection group. Select Execute DR Plan. Notice the pre-checks are enabled by default. You can uncheck this to save some time if you are confident everything is going to work. I lack that confidence, so I'm going to leave pre-checks enabled. And now select the single button that triggers the execution. That's it. That was the entire process for initiating the recovery for any business system, no matter how complex or how many steps it takes to recover. You can execute DR plans for other business systems once the recovery team is confident things appear to be running smoothly. Personally, I would wait until the pre-checks have completed successfully before executing DR plans for other business systems. Now let me show you a few things about the UI while we wait for the switchover to complete. Don't worry too much about the terms I'm using to describe things. I'll explain terms and technical concepts in the next video. Let's take a quick look at pre-checks. Pre-checks validate the readiness of various things like replicated storage if you've added volume groups as members. It ensures DataGuard is ready for switchover or failover if you've added one or more databases as members. And it checks to see if stopping VMs at the primary site and launching VMs at the standby site are likely to succeed. It also ensures any subnets you specified for VNIX at the standby region haven't been accidentally deleted by somebody. If you are executing a switchover like I am here, then the pre-check ensures readiness at both the primary and standby regions. If you are executing a failover, then pre-checks only ensure readiness at the standby region. Let me show you one more thing. This is called a plan group. Plan groups contain one or more plan steps like this. If this step encounters a problem, full stack DR will allow you to solve the problem, then return here to either skip or retry the step again. You can also view the log for each plan step. Like our competition, you can cancel the entire D operation if things are going horribly wrong. However, something we offer that our competition doesn't is the ability to temporarily pause the DR operation, fix whatever problem you encountered, and then resume the DR operation where it left off. Full stack DR also keeps track of how long individual steps and groups of steps are taking to complete. The switchover is now complete. The very last thing I'm going to show you is the duration time. For those of you that want to know exactly how long it took to recover a business system, this shows the entire time it took to complete a switchover or failover. The total duration time for a failover is probably a better number to use when trying to track the recovery time because failovers only execute steps at the standby region. That's it. I'm going to take it.
All right, I'm going to stop it there and go back to here. And I'm kind of a little behind here. I'm taking up Surge's time, so I'm going to go a little quick here. You saw my app 01. This is it again. This is going to be the new version. I'm waiting to get a couple of approvals to make sure it's okay with other business or other applications to show what I'm about to show here. This is the members that I was talking about. So you're going to see a lot more in this video than that basic video that I just showed you. I'm going to make exactly the same kind of video, but now you're going to start seeing more things in it so you can get the idea of what this really does. It doesn't do just an application. Nobody has just eBusiness Suite or just PeopleSoft or just JD Edwards or whatever, right? They have e-business suite with their own homegrown applications built around it and multiple databases that go with it and OAC and OIC and OAC and all kinds of different things. And what I'm trying to get across here is that you can, in a single button push, like I just showed you in that other video, is you can orchestrate all of those things at the same time that belong to the same business system. And that's a very important to understand. So these are the members that I was talking about. I went over here to members, and these are plans. I've got plans on the right-hand side, members here on the left-hand side. I just want to show you, you add these members. Here's autonomous databases in here. Here's a database for eBusiness Suite. Here's a bunch of different compute instances for different things in here. Here are file systems that Suraj is going to talk about a little more. And then there's load balancer and there's volume groups. And we have more coming. As we grow, we're going to be adding more and more member types in here. And when you see that, now I can go up here. I'm going to go ahead and hit this. And now I can create a plan. I can't create it here because I'm in primary. I have to be in standby. But when I'm in the standby region, I create a plan right here. And then it's going to build something like you see on the right-hand side of the screen. So when it is, I push that button right there, and it's going to build this that has all of these things that say built in. See, if you this right here, these are all the things that you need to do during a DR recovery operation, a failover or a switchover. These are things that we've already figured out how to do for you. You don't need to figure this out. You don't need to add this in here. We're going to do it for you. Now, here's things that we don't know how to do. Right, you're going to add things in here because there is no way anybody on the planet that any kind of cloud provider is going to know everything you need to do. You have a lot of things that are unique to you, right? And we give you a chance to add those unique things or things that we don't know how to do here. And I just want you to see this. So, just so you get an idea. I mean, we're doing all of these things for you. Which is very, very important. And it's all those things together get you ready after you've done a switch over. It gets you ready to switch back to the other region when you want to. And you don't have to do anything. We're going to keep track of all that for you. But look at these kind of things that you can add in here. This is DB Visit is a marketplace app out there or service that you can use to back up and restore standard edition. So if you have databases that you don't want to do use DataGuard for, and you want to just do a restore, you can, and you can use it with this product. And this is just one example product, this DB Visit. You can also stop eBusiness Suite or PeopleSoft or JD Edwards or whatever you want. And these are things that you have to, you're going to have to, how you want to stop e-business suite. Okay. Now you need to follow their directions. E-business suite has specific things you need to do, and you're following those directions. But we'll have this for you, so it's kind of ready to go. Now you still have to add these steps. Now you have to. Here's where you're disabling that rsync job that e-business suite uses. Okay, we don't have any requirements for doing rsync or anything like that. That's an application level thing. We're going to stop OAC here, the Oracle Analytics Cloud. We're going to stop OIC here. And we're going to stop these homegrown applications or non-Oracle applications right here. And then we're going to do all of these things Suraj is going to talk about, including unmounting file systems that we're going to then move over to the other region and remount. We are going to go down here and go through all of these things and remount everything and launch the compute instances if that's what you want. I should mention let me stop here, go back over here. You can combine what we call moving and non-moving compute together into the same plan. So some of these things are already for e-business suite. The application is already installed and on a host that's running in the standby region. You can do that too. So it's not just VM failover. We can do a combination of both, or all of the above. All right. So in here, this is how you have applications that have to start up in a certain order. This is how you handle it. All right. I put them into group 1, group 2, and group 3. So before these can get started here, all of these need to complete successfully. So I'm going to open it up, and we're just going to really quickly. So all of these things in here, these all have to complete first. And these are run in parallel. So every one of these things is going to start at exactly the same time. Okay, that's why I have to divide them into groups, because whatever's in this group, they're all going to start at the same time. All right, and then I go down here and I do this. This is where I start DB Visit agents and start eBusiness Suite and enable eBusiness Suite. And then here is where I update DNS for 2 different things. There is a DNS for everything in here. And then there's update for a special little update for OIC, DNS update. And then we're restoring the standard edition with DB Visit here. And then we're registering Oracle Analytics Cloud and enabling, and there you go. So you can make these very complex plans and execute. Everything is still executed with a single button. All of those things are going to be done. Anyway, that's what I wanted to show. I'm going to turn this over to Suraj now. If you don't mind, I'm going to stop my share, and Suraj, it is your show now.
Okay, thanks, Greg. I'm sharing my screen. Okay. So the first thing I just want to put out here is what are features thing which I'm going to talk about. I've just pasted in the chat with all the links to the blogs and the videos, right? So in case if I'm going too fast or if you're not able to get the concepts here, you can read the blogs and also watch the videos, right? So that's the first thing I want to share it. Okay, so before I explain the new features, right, I just want to spend a minute to quickly explain a difference between what is moving compute and the non-moving compute, right? That is something I use a lot during my explanation, right? So the moving compute is basically in full stack DR topology, where you have your virtual machines where you have your applications installed only in the primary region, right? So your VM is always there in only the production region or the primary region, right? So that's what the moving instance. So during the switchover or failover or the DR drill plan, the virtual machines will be automatically created during the DR runtime operation, right? So that's what a moving compute or movable compute means. Non-movable, as the name suggests, it is exactly opposite to that, right? So that means you have a virtual machine in both region, right? So in primary region, your users will be serve traffic that will be acting as your primary region. And in the DR region or standby region, your virtual machine will be installed maybe with a minimal OCPU where all the applications is installed. And during the runtime operation, the new VMs running in the DR region will start serving the traffic, right? So this is something I just want to make sure you understand this concept in case if you're not aware about these two concepts, right? So with this, I will go to the new features, right? So last year, right around October end, we started supporting these two number types and also the new DR drill plans, which Greg mentioned, right? So we have member type support for a load balancer as well as file storage, and we introduced the DR drill plans where you have two types of drill plan. One is start drill and stop, right? So these are the main features I'm going to explain in next 15-20 minutes. Okay, so I will start with DR drill plan, right? So what is DR drill plan? So basically the DR drill feature allows you to create a copy of a production stack in the standby region for doing a DR mock testing, right? So basically it won't impact any production stack at all. So we don't touch anything in the production stack. So this DR plan will be really useful for customers who want to do mock testing every quarter or so, depending on your requirements, right? So without touching anything in the production, if you want to create something in DR region in isolation, then DR trans would be ideally a really useful one for do that, right? So we have built-in members, support members for all the members like compute, volume group, autonomous database, file storage, and load balancer. So if you add these members in both primary and standby protection group, depending on the topology, then if you create a drill plan, then you'll see a built-in plan groups created automatically for you. Only exception is the base DB and ExaDB. In case if you have these databases added into the protection group, then we don't currently generate built-in plan groups for that. The reason is for both database service, right? There is no native API available for converting a physical standby to snapshot standby and vice versa, right? So already those cloud services team or engineering team are working on priority to provide that functionality. So in the meantime, if you have these two database system, and then if you want to use tilt plan, then you have to use user-defined plan groups and scripts for converting those databases. I mean, from physical standby to snapshot standby for start drill, and then snapshot standby to physical standby for stop drill, right? So this is something very important to understand, because if you have these members and then you create a drill plan, you don't see a built-in plan groups automatically created for you, right? So if you have want to take advantage of, then you have to use a scripts for that to do that. Okay, so as I mentioned, we have two types of drill plan. One is start drill plan. So start drill plan creates a replica of your production stack in the standby region, right? Identically what we do for a failover plan. So it basically creates compute, file storage, whatever you add as part of a member without touching anything in the production. And then similarly for start drill plan, we remove the replica of the production stack which was created during the start drill plan, right? So it does exactly the reverse. What are the infrastructure which we spin up and all the artifacts which we create as part of the DR drill plan will be automatically removed when you go ahead and execute a start drill plan. So this is at high level. So in this slide, what I'm explaining here is, let's say if you have a member type only as a mobile compute, right, where you need to add your volume group for that, then if you try to create a drill plan, these are the plan groups you will expect, right? So you'll see a plan group created for activating your volume groups, right? That will basically, I mean, based on the replicated volumes, right? We'll go ahead and activate the volume groups. And once that is done, then we launch the new VMs in the standby region. And then if you have customized your drill plan with any user-defined plan groups, then we'll go ahead and execute as well. This example just shows only the mobile compute. In case if you have members like autonomous database file system, then you'll see a similar plan groups created automatically for you, right? So let's say for the same example, if you have added an autonomous database, then during the start drill plan, we'll go ahead and create a refreshable clone database automatically. But I'm just showing here a quick example, a simple example. But depending on your topology and the members, right, then you'll be able to see a bunch of plan groups created automatically for you. The only exception, as I mentioned, if you are using a base DB or ExaDB, then you have to create a user-defined plan group for doing the database role transition. So in this slide, I'm just showing the reverse, right? Like if you create a stop drill plan with a mobile compute, whatever we have, then what we do is we create a plan group for stopping and terminating the compute, right? So whatever the VM which was launched during the start drill plan, will be stopped and be terminated automatically. And then the volume groups will also be taken, I mean, terminated automatically. And if you have customized any user-defined plan groups, that will be also executed, right? So if you see this, right, whatever you were, I mean, what are the things which were running as part of your infrastructure before the drill plan, you return back to the original state, right? So that's what I was telling. Like this plans will be really useful, right? If you want to test your DR region with your application, creating virtual machines and database, putting into the read write rule, then this plan will be ideal use case for testing it out. Okay. So second new feature I'm going to talk about is the load balancer member type. So load balancer, like previously, customers has to handle through the user-defined groups. So with the load balancer type, we will automatically generate the built-in plan groups what we do for the other members. So the load balancers, you can add both application load balancer and then network load balancer. So if you are using any of them or either of them, then you can add the load balancer as a member into the DR protection group. And the load balancer can be public or private. So what we expect as a prerequisite in terms of load balancer is like you have to pre-provision the load balancer in both production and the DR region, and you have to configure all the necessary things which you do as part of the load balancer, right? So example, we expect you to create the backend set, listener, health check policies, whatever you need, I mean, you do as part of the load balancer configuration, that is something has to be created as a prerequisite for using this functionality within the full stack DR. So once you do that, then you can add a load balancer as a member in the both primary and the standby protection group, right? So when you select a member, we'll ask what is the source backend set and what is the target backend set. So you'll get a dialog box where you can specify the details while adding as a member. So load balancer is tied in with the compute, right? So whenever you want to add a load balancer, then whatever the backend sets which is part of the load balancer, you have to add the dependent compute. It can be moving or non-moving as a members in both primary and standby protection group, right? So example, if you are using moving topology, then we expect you to add the only the into the primary protection group of the right, DR protection group, right? So basically, you'll add only the moving instance in the primary DRPG. In case if you are using a non-moving instance, which is part of the load balancer, then you have to add both non-moving compute instance in the primary and the standby DR protection. So once you add that, define the topology, what you need to do, then you can go ahead and create the plans, and then we build, I mean, do the plan generation for you. So these are the things which we do at high level, right? So if you have a moving instance, then what we do is during the plan group creation, in the primary region, I'm talking about the switchover. We will remove the backend servers from the backend sets in the primary DRPG, and then once the computes are launched in the DR region, then we'll fetch those private IPs automatically, and then those backend servers will be added to the map backend sets automatically. So that's what we do for a moving instance. If you are having a non-moving instance, then we basically drain the backends, right? So we during the switchover, we set the status to true, and then in the DR region we set it to false, right? So in short, currently we basically handle the backend sets configuration, backend server configuration as part of the DR runtime execution, right? So this is what we do as part of the load balancer. And one more point to important thing to highlight is you have to map a load balancer backend set configuration individually. So you cannot mix and match a moving and a non-moving in a single set. So you need to have a separate backend set if it is a moving or if it is a non-moving, right? So you have to take care, and we have documented all these prerequisites in our documentation. Okay, so a quick example what we do, what I've explained. So this is a simple example with a moving compute, right? So we have a moving compute here in the primary region, and then we have the necessary block volume replication, and then these are the load balancer, right, with all the required configuration in primary and the standby. And once you have these members and go ahead and create a plan group, the plan, then these are the steps which we create automatically for the switchover, right? So in the primary region, we update the source backend set, right? Being it's a mobile compute, we will remove the backend servers from the backend set automatically. And then, excuse me. So this is for activating the volume groups, that is for compute. And then we go ahead and launch the compute instance. And then in the DR region, right, since it is a mobile compute, then we'll fetch the private IP. And then based on the mappings, we'll add the backend servers to the backend sets automatically. And of course, if you have any user defined plan groups, if you are defined as a part of plan, that also be executed as part of the overall plan, right? So just to wrap it up, for the load balancer, what we do is, depending on moving or non-moving, we help you to uh, automate the process of the backend servers in the backend sets. That's what we primarily do at the moment for the load balancer. Okay. The third feature I'm going to talk about is the file storage, right? So in the protection group, now you'll have an option to add a file storage as a member to the DR protection group, right? So file storage, as you know, it's an NFS kind of storage which OCI provides, right? So depending on your configuration, you need to add the file storage into the primary protection group, and we have a bunch of prerequisites we expect you to do to use this functionality, which is documented. But high level, what you need to do is you need to create a mount target, right, in both the primary and the standby DR region, and then create the file system in the primary, and then set up the replication. So file system has a built-in replication capability. So you have to set up the cross-region file system replication based on your primary and production group, I mean standby protection group. And once you do that, then you have to create the export path in the primary region, right? And of course, you need to modify your security list and NSDs to flow the traffic between the both primary and standby region. So once you do all the necessary prerequisite, what we expect you to add in the protection group is what I'm going to explain now, right? So file system is something which you mount into the compute instance, right? So you can define both moving as well as non-moving compute with wherever you want to do unmount and non-mount, depending on the DR plan you are creating, right? So what you can do is, once the primary file system is added into the protection group, then the necessary members, like you, based on if there is a moving or non-moving, then you get a dialog box to choose these are the file system you want to add, right? These are the mount points I want to add. So you can specify the details in the compute. And once you do that, then you can create the plan types depending on your requirement. So you can create switchover, failover, and start drill. Depending on the plan, we create the built-in plan groups automatically for you, right? So this is what we create during the plan execution. We generate plan groups for restoring the file system, and then unmounting the file system in the primary region, and then mounting the file system in the DR region. And then once it is done, we also create a group for doing the reverse replication of the file system, right? So this will be key in case if you want to switch back from the new primary region to the DR region. So let's just see a same thing, whatever explained in a steps or visualization, right? So here I'm using a simple topology, right, where I have a moving instance, and then I have a file storage, right, where I have created the replication setup, and then for the moving instance, I've set up the block volume replication as well. And then I have defined the properties in the member properties of the compute. This is the file system I want to use, and this is the mount point I want to use in the compute. So once you do that, based on the plan you create here, I'm showing as an example for switchover. So switchover means we do everything in the primary, and then we do a task in the DR, right? So the first span group will be created for unmounting the file system from the compute instance. The second plan group will do a file store switch, I mean, switchover file system, right? So internally it deletes the replication target and creates the file system in the new primary region. And once it is done, since we have a moving compute, we'll go ahead and launch the compute instance. And once the computes are launched, since we already have the mapping in the member property, we mount the file system to the compute instance which is launched, and we do the reverse replication automatically for it, right? So you can see, like, provided if you define your prerequisite, I mean, complete the prerequisite and define this property, then we automatically help you to mount the necessary file system in the new primary region for you at scale. Okay, so this is the last feature I'm going to talk about. So just to give a quick background of this feature. So for moving instance, right, whatever I showed you, we whenever you use a moving compute instance, we take advantage of the cross-region block volume replication. So based on that, the volumes will be automatically mounted into the new compute instance there, right? But for non-moving instance topology, right, before this functionality, customers have to, if in case if they are leveraging the cross-region replication, they have to use a user-defined group to attach the replicated volumes into the compute instance, right? So that feature, that function can be completely overcome with this new feature, right? So if you have any requirement where you are leveraging the block volumes and then you have a non-moving instance, then we have a built-in plan group automatically provided for you. And also we have a nice feature where you can specify in the compute member property, non-moving compute property, to stop and start the compute instance, right? So there are a lot of customers who keep their TR non-moving compute in a stop state to avoid, to reduce cost. So if you have that kind of a thing, then you can specify the member property so that we provide a built-in plan groups automatically for you, right? So with this, I will just explain more in details, right? So since we are talking about block volume, you have to add a volume group, right? So you have to create a volume group replication for the block volume and then add as a member in the primary protection group. And then, of course, you need to add your non-moving compute in both primary and the DR protection group region. So while adding it, you have an option to say, hey, this is my mount point and block volume. I want to unmount it in the primary region. And once the replication is done, I want to mount it in the new primary region, right? So once you specify that member properties, then the full stack DR will automatically generate steps for you to complete this task. Okay. And optionally, as I mentioned, you can also specify there is a checkbox where you can say, hey, I want to stop my compute instance in the primary region and then start my compute instance during the plan execution. Right. So if you want to do take advantage of that functionality, then you have an option to specify that as well. So once you do that, add the members, right, depending on your requirement, then you can go ahead and create the plan, right? So once you create the plan, you'll see all these plan groups created automatically for you, right? So you will get a plan group to detach the block volumes and then volume group activation, and then attach the block volume and do the reverse replication for the volume. And all will be taken care by the full stack dev service. Okay, again, this is just going back like similarly what I've shown for the other examples, right? Other features, a quick diagram depicting what I've just spoken. So we have a non-moving compute in both primary and standby region. So whatever the block volumes which is part of that compute, we have to create the volume group replication, right? Once you define the member properties, then we provide the steps for detaching and attaching the block volumes and also stop and start compute, right? So these are the plan group. Again, just to quickly explain, this is the order we create, right? So you'll see a detach unmount block volumes from the primary compute instance. And then if we've specified a checkbox to stop, then we will provide a plan group automatically for you. And then you'll see a plan group for activating the volume groups containing the replicated blocks. And then you'll get a step for attaching and then mounting the block volumes to the compute instance. And then we'll also see a start compute instance in case if you have specified the checkbox. And of course, if you have any user-defined plan groups, then you can customize the plan as well. Okay, so I have explained all the new features again, as I mentioned, right? I've tried to explain at high level, but in my chat I've posted the deep technical blogs as well as the video links where you can watch it on your own pace, where we have explained in detail how to take advantage of these features. Okay, any questions, Santosh? We have any open questions which you want to answer, Greg? We have still
No, the only thing I
10
saw in the
minutes.
questions were the ones about pricing. I don't know if we want to talk about pricing or how we have a pricing calculator on our for those of you that are curious about it. There is a cost. This is over and above. We're like an insurance policy, right? So there is a cost for this over and above the your standard OCI services. Because like Suraj said, you set everything up in standard OCI, right? And then after you got everything set up, then you use full stack DR, you add it and then create these plans. Let me share my screen real quick. Do
Okay,
we want to? Oh
no,
no,
you
go
can.
ahead. No,
Uh,
that's fine. Put it
okay,
back
I
up.
just I just
wasn't
opened it
paying
up, so
attention.
maybe, yeah. Okay.
Yeah, so you can
Yeah.
go to our product page and slide down there. Now, go to the top there real quick. I just want to mention this. So that first one's going to be going away because it's a little confusing with that vCPU thing in there. That's not relevant. Scroll down on the next one. Anyway, you see this. There was those prices were just kind of ambiguous. This is how much it costs an hour. But if you want to figure it out, do like Surge is doing here. So how many do you have? And so on standby region, Surge, go and if you're going to do VM failover kind of thing, which is what a lot of people want to do, then you'll have 0 there on the standby region protection group for OCPU. Well, wait, and then for your database, oh, I see.
I think something is missing here. I think this is for compute and
Yeah, that's
database.
weird. Yeah, that's really weird. Okay, so let me see if mine's right. I think they're doing some adjustments to that, but that's not
Yeah.
fun. Dot.
Basically, while Greg opens, right? This is for compute and this is for database. We have a separate tab saying this is for compute and database, and this is for compute and database. So depending on the topology, if you put the OCPUs, then we just tell you this is the monthly cost of using the service.
Yeah, here, let me share my screen. I don't know why this is. All right. So like Surge had on his, you can see this now, right, Surge? It should have, it should have had this total. Oh, let me scroll in a little bit. It should have had total compute, OCPU in this primary region. So you put the compute in here, and let's say you've got, a total of 64 OCPU here. And then your database is 32 OCPU. And then you have a standby database, and it's 32 OCPU. And you don't have any, and all the virtual machines exist here, and you want us to move it to the other region, then this is how much it's going to cost you a month. This is retail, okay? And this is US dollars I'm showing here. Anyway, that's how much it would be for a monthly cost for that much right there. Now you might have, if you're using EBS, 64 of this. Let's just say I'm going to make numbers up here. I'm not very good with math, to be honest with you. 48, and then maybe you got 24 over here. These are those non-moving compute there, right? And then over here, then if you're using autonomous database or something like that, you have to have 32 and 32. But maybe you have a base database or something like that where you can have 16 over here for your standby database, right? Then there's your cost there. Now, let me go back to this example right here. If I go back to 64, where I had it here and 0 here, after you do a failover, and let's go back to this one where we had 32 and 32. After a failover, basically these two numbers are never going to change because you got this one becomes the standby, this becomes the primary, right? But these change from here. So notice the cost is 1,218. Then I move everything over to here, and now it's still 1,218. Okay, so you don't have to say, you just say where I have things running right now, not where they're going to be running. Just tell me where they're running right now. I got 64 OCPU running here right now. There is nothing in this region from virtual machines there, and then that will give you the price. Okay, don't worry about what happens after a DR operation. It'll still remain the same cost after a DR operation. All right, anyway, I just wanted to show that off because somebody asked about that. I'm going to stop share. And that was about it. That was the only other question I had, or I thought I saw there. The DNS, we covered all that. So we're done.
Okay. So, Maria, do you want to take over?
Yes. Okay, great. So yeah, thank you so much everyone for joining. We really appreciate you taking the time today. And special thank you to Suraj and Greg and Santosh for presentation, demo, and managing the Q&A as well. Thank you so much for all your questions that we have received so yeah, we are ready to conclude then. So feel free to drop from the webinar as you like, and we really hope to see you next time. Thank you so much.